Well, it looks like it's that time, so I want to say aloha, everyone, and welcome to a special presentation hosted by Maui Nui Marine Resource Council that will be bringing you the latest results from a unique citizen-based ocean water quality monitoring project here on Maui called Hui o ka Waiʻola, with details about how the data can impact the management of Maui's watersheds. We're all very excited that you're here. I'm Darla Palmer Ellingson, your MC, and I'm also the local radio show host of the public affairs program Island Environment 360, Maui's only commercially broadcast public affairs show on environmental and related Hawaiian cultural topics, aired on the stations of Hawaii Media. Tonight's presentation is part of Maui Nui Marine Resource Council's monthly Know Your Ocean speaker series, usually held on the first Wednesday of each month at 5:30 via Zoom. And this monthly series is supported by the County of Maui Mayor's Office of Economic Development. Just a few things before we get going. You'll notice that your microphone is on mute. Please keep it on mute during the presentation to avoid distractions. We invite you to submit questions using the Q&A feature at the lower edge of your screen. And sometimes you have to kind of mouse over that to be able to see that menu. We will leave time at the end of the presentation to answer your questions. We have a wonderful presenter for the evening, Tiara Stark. But before I get to that introduction, I did want to note that Tiara will be joined by Tova Callender from West Maui Ridge to Reef and Kim Felinsky from the Nature Conservancy during the Q&A session. So make sure and stick around for that after the presentation. And now it's my pleasure to welcome Tiara Stark. Tiara is a Maui native who grew her conservation skills here in Hawaii through research projects on marine mammal behavior, coral reef ecology, population genetics, and fisheries management while pursuing a BS in marine biology from the University of Hawaii at Manoa in 2014 and an MS in 2018 in evolution, ecology, and organism biology from Ohio State University. Currently, she works in Maui with the Nature Conservancy and Maui Nui Marine Resource Council, where she leads various projects on coral bleaching monitoring and community-based marine management. She is the senior team lead of Hui o ka Waiʻola, a citizen science ocean water quality monitoring program that you're going to be hearing about. So please join me in welcoming Tiara to our Zoom stage. Welcome, Tiara.
Thanks, Darla. Thank you for that great introduction. Aloha kako, everybody. My name is Tiara Stark, and I am the senior team lead for Hui o ka Waiʻola. I just wanted to thank you all for tuning in, and we look forward to sharing how our long-term water quality data set has revealed trends which will help drive watershed management in Maui. So today I'll quickly provide an overview of the Hui, highlight some hotspots and trends, and discuss some possible solutions. And we'll also address whether or not we've observed any changes in our water quality data during COVID, and then we'll have some time for questions. So as we all know, coral reefs are culturally, economically, and ecologically vital to the livelihood of the people of Hawaii and Maui. They serve as critical habitat for marine life. They generate billions of dollars through providing jobs in fisheries and tourism, and they protect the coastline from storms and waves. However, both global and local stressors are degrading Hawaii's reefs. So while it's difficult to directly address and reduce the impacts of global stressors like climate change, it is possible to focus on local controllable stressors, such as those impacting coastal water quality. Coral reefs are fragile and very susceptible to even the slightest changes in ocean parameters. So measuring coastal water quality can really help us understand the dynamics of an area so that we can better protect those coral reef ecosystems from harm, as well as improve the resiliency against other stressors. The Department of Health is responsible for monitoring coastal water quality and comparing their findings to Hawaii state standards for coastal water quality deemed safe for people and the environment. And to bolster the state's efforts, the concept of the Hui was born, believing that citizen science volunteers can be trained to collect water quality data to the standard of the state. and we found that they absolutely can. In 2013, 3 organizations, the Maui Nui Marine Resource Council, the Nature Conservancy, and the West Maui Ridge to Reef Initiative, initiated a 3-year process of developing a quality assurance project plan, or a QAP, that mirrors DOH, or the Department of Health's procedures for gathering quality assured data. So once the QAP was approved by the Department of Health, the Hui was officially established in 2016. And Hui o ka Waiʻola is the first citizen science-based water quality monitoring program of its kind in Hawaii. And since then, we've had over 50 volunteers join our program. We also have 4 team leads in our program who help coordinate volunteers and prep equipment for sampling. Lastly, we have a steering committee and subcommittees, and they look at long-term direction and goals and guide the program to success. And together, we all work toward our mission of deepening the understanding of Maui's coastal water quality through science and advocacy to accelerate positive change. So the Hui samples 12 water quality parameters across 29 sites in Leeward Maui, stretching from Ahihi Kina'u Natural Area Reserve in the south, all the way to Honolulu Bay in the north. All our data is publicly available and can be found on our website, huiokawaiʻola.com. Physical parameters we test for include pH, dissolved oxygen, temperature, salinity, and turbidity. And chemical parameters we test for include nitrate, ammonia, total nitrogen, phosphate and total phosphorus, and silicates. As we approach our 75th sampling in South Maui and 100th in West Maui, can you believe it? That's a lot. We're now in the stage of moving beyond just establishing a baseline for how water quality is at our sites. So with the goal of moving data into action, we've analyzed data that we've collected thus far to see if there are any obvious correlations to changes in data parameters versus what might actually be going on in the area. We also want to move toward working with partners to identify actionable solutions at scale. So through analysis of this long-term data set, we can ask questions like, is new development causing increased sediment and turbidity in the near shore? Or are upgrades in sewer infrastructure leading to a decrease in nutrient pollution? So do we know what is causing pollution in the area? And can we come up with solutions or changes in the watershed to prevent or decrease the pollutants in our coastal waters? And finally, are those solutions working? So in West Maui, the primary issues are high turbidity or low water clarity and high nutrient levels. Elevated turbidity from suspended particles has been shown to negatively impact adult corals by reducing their access to light. So corals require light because they host algal dinoflagellates, Symbiodinium, from the genus Symbiodinium, that provide corals with energy for survival. And in West Maui, turbidity exceeds the state standard of 0.2 NTUs, or nephelometric turbidity units, at all 19 sites that we monitor. In South Maui, the issues are actually swapped. So high nutrient levels are the primary issue, followed by high turbidity. The latter, which is less of an issue just because there's a lack of rainfall and streams in South Maui compared to West Maui. And when nutrients are in excess, they can encourage an overgrowth of algae in the ocean, and that can disrupt the chemical balance and overall health of coral reef ecosystems. So here we have a graph illustrating turbidity at all of our sites, going from Honolulu Bay in the north to Ahihi Kina'u Natural Area Reserve in the south. You can see that turbidity is more of an issue in West Maui and less so in South Maui, especially after the cove. It's super important that we know the cause of high turbidity at sites so that we can appropriately address it. So high turbidity levels can be driven by a few different drivers. One of them being stream inputs of sediment, coastal erosion, or resuspension of sediments. And in many cases, it can be driven by a combination of these three. So you may be wondering why streams carry so much sediment to the ocean. Well, a lot of these streams actually pass through areas flanked by fields formerly farmed for pineapple for over 100 years. And agricultural practices like pineapple replaces natural vegetation, which would normally stabilize the soil. So this results in loosened, less fertile soil, which can then be blown or washed away, accelerating erosion. And agricultural practices actually introduced over 10 times the background level of sediment into stream beds and banks. And this sediment is and will continue to make its way through the system for an unknown period of time. And another major source of sediments are invasive ungulates. So stuff like axis deer, they eat native plants and loosen the dirt and intense fires. So both of those also lead to erosion and runoff of sediment as well. For example, streams near Honolua, Kahana, and Ka'opala in the northwestern region have some of the highest turbidity levels from stream inputs. So on more than 40% of sampling days, these sites exceeded turbidity levels of 10 NTUs. Consistent high levels of turbidity in this area likely drove the collapse of all major coral reef tracts in this area. And today only patch reefs remain, but we can see extensive pavement as evidence of historic reefs. And we also see high turbidity from stream inputs at Papalawa near the Pali. So just to give you an idea of how turbidity affects visibility, here's some photos that Dina Reed and Bill Rathfin took at Kapalua Bay while they're snorkeling. So this visibility is around 1 NTU, so you can only imagine how it would look around 10. In terms of trends in West Maui, we do see an increase in turbidity at our Papalawa Pali site. And this could possibly be due to not only the stream, but poor forest management and stormwater runoff. And ultimately, additional investigation into sources such as fire and invasive ungulates will be required to really pinpoint what's going on. In South Maui, high turbidity levels from stream inputs exist at Waipuʻilani Park. So here there's 2 gulches, Waipuʻilani Gulch and an unnamed gulch that flow through the central and northern portions of the beach park. Waipuʻilani Gulch is prone to surface water flooding during heavy rainfall, and that's whether rain is localized or happening up in the mountains. And subsequently, large amounts of sediment are deposited into coastal waters after storm events and resuspend when there are waves. So overall, sites with turbidity primarily driven by stream inputs have not notably increased or decreased over the years. So it's pretty stable. We see pretty stable trends here. Turbidity can also be driven by coastal erosion. So over time, sea level rise in conjunction with wind, water, and wave action can wear away the coastal land or beach, and this increases suspended sediment and turbidity. This is a huge issue in West Maui, especially in the Kahana area. So I'm sure a lot of you listening in here have seen that and noticed that in Kahana, coastal erosion has been gotten really bad. In the Kahana area, it is due to more severe and more frequent wave run-up events and subsequent erosion from sea level rise and climate change, threatening coastal development and infrastructure. And another coastal erosion hotspot is Pohaku. And this site is actually the highest site for turbidity known to be driven only by coastal erosion in West Maui, with about 20% of sampling days having values of over 10 NTUs. And this is also a major issue at sites as you move south toward the Pali. In terms of coastal trends, or coastal erosion trends, our data has supported an increase in turbidity at sites where coastal erosion is worsening. So this includes Napili Bay and Kapalua. So this photo here is of Napili Bay, and it illustrates how a king tide event in 2017, which is the highest predicted high tide per year, so that's what the king tide is, can speed up the process of coastal erosion, in turn increasing turbidity. So this 2017 event resulted in turbidity values just under 20 NTUs. And if you look at our little plot there, it's the first major peak here on this time series. Then the latest king tide event in 2019, which is that third really, really large peak, resulted in turbidity values around 81 NTUs. So if this is an aerial photo of 20 NTUs, imagine what 81 would look like. In contrast, we've observed a decline in turbidity at Ka'anapali shores near Honoko'ai stream mouth. Possible contributors are increased maintenance of Honoko'ai Dam and to a greater degree, temporary shoreline stabilization work along the Hono-Kauai coast. So you can see from that time series, there is a decrease there. In South Maui, wave run-up and coastal erosion are drivers of turbidity at Haycraft Beach Park and Mauiʻs oi Ia'u. And erosion in this area can be intensified by seawalls. And our data does show that this trend is increasing over time. The last major driver for turbidity is resuspension and circulation. So once deposited on the seafloor, resuspension of sediments and lack of water circulation can further increase turbidity. Hotspot sites in West Maui with high sediment resuspension include Oluwalu, Polonui near 505 Front Street, and Lahaina Town. And this is likely caused by recreational activities and wave action, as well as a lack of water circulation on the coastal side of these remnant reefs out there. So for example, in this photo, you can see here, one of our volunteers stirred up all of this sediment just by walking out to take a sample. So you can only imagine what like waves and tons of recreational activities could do. A hotspot for resuspension in South Maui is Haycraft Beach Park. Here we see steady erosion from wave run-up events, and that has exposed this dark red mud under the sand, which gets resuspended, especially during swell events. And this pattern has continued over time, continued to worsen over time. So as you can see, we outlined the different problems that lead to high turbidity. Storm events are delivered by streams and can cause elevated turbidity for a long time, even after the storm. Most of the sediment, up to thousands of tons, is delivered by surface water this way. A newer upcoming problem, though, is coastal erosion, which can cause moderate turbidity increases. And lastly, in some places, sediments that were delivered a long time ago are resuspended because there's not a lot of wave energy. So work to identify which sites are affected by which turbidity problems is definitely ongoing, and solutions to these drivers are being investigated. For example, possible solutions include maintaining upland vegetation through controlling ungulates and fire, which may help mitigate sediment runoff, and prioritizing dune maintenance or seeking green solutions to coastal infrastructure, which may help reduce coastal erosion. However, it is important to remember that sediment can remain stuck in the system for a long time. So, we have to temper expectations. So nutrients are the primary water quality issue in South Maui, but are secondary to turbidity in West Maui. Elevated nutrients from human activities, such as nitrates, can enter the nearshore waters through submarine groundwater discharge or stream and storm runoff. When nutrients are in excess, they encourage an overgrowth of algae in the ocean, and this can disrupt the chemical balance and overall health of coral reef ecosystems, increasing coral disease and weakening coral reef structure. The two major sources of anthropogenic nutrients are agricultural practices or wastewater. And similar to turbidity, there are many cases in which signatures of both agricultural and wastewater derived nitrogen are present. However, unlike turbidity, the source of nutrients are a little bit harder to trace because you can't really see it. Therefore, we try to seek source detection methods that are kind of just a step beyond that basic monitoring. So one such method the WHO used to identify potential sources of excess anthropogenic nitrogen were analysis of stable nitrogen isotopes, in particular delta N15, in the tissue of limu or seaweed. And this method was applied to a number of sites, a number of our hui sites with high nitrate levels. So here you can see the nitrogen levels across all of our sites, again, going from Honolulu Bay in the north to Ahihi Kina'u in the south. You can see that there seems to be a concentration of hotspots in West Maui from Kapalua Bay to Waihiukuli Park, and in Ma'alaya from Ma'alaya Harbor to Haycraft Park, and in Kihei from Kihei Canoe Club, to Cove Park. So Cove Park is also our site with the highest nutrient levels. And this site, along with some others, are up to 25 times the standard. So I mean, just looking at this graph, you can see the Cove is just crazy high compared to all of the others. In West Maui, nutrient hotspots with large wastewater signatures derived through groundwater are Pohaku, Canoe Beach, Kapulua Bay, Napili Bay, and Ka'opala Bay. So historically, plantation agriculture dominated the mid-elevation of the landscape above Pohaku and Canoe Beach. And after heavy rainfalls, you'd expect stream flow in these areas would bring legacy sediment down to coastal waters. However, Kuiokawaiola and additional nitrogen isotope studies have found proof of wastewater signatures at Napili Bay, Kapulua Bay, and Pohaku. So it's definitely a combination of sources. In terms of trends, we see nutrient levels in West Maui are significantly above the state standard at many sites. Levels are also relatively stable with the exception of Kapulua Bay. At Kapulua Bay, we did observe a statistically significant drop in nitrite nitrogen, coinciding with sewage infrastructure upgrades by the County of Maui in spring 2019. So while we can't prove that it was the upgraded sewage infrastructure that improved water quality, it certainly seems likely, and we do plan to follow up and to verify if there is indeed a correlation. And this is a pretty cool observation. It really, really highlights the importance of long-term data sets and how we can really, check and determine whether management actions are working. In Mauiʻs, sites are influenced by both nutrients derived from legacy agriculture and wastewater. So large-scale sugarcane production utilized fertilizers and other nutrient-laden soil amendments for many years up in this area, and these continue to make their way to the nearest shore through submarine groundwater. In addition, nitrogen isotope work suggests that these sites are also influenced by wastewater injection wells from coastal condos and resorts. And wastewater facilities at the harbor and the boat ramp might be investigated as sources, given the additional possibility of on-site sewage disposal systems at these sites. And so here's just a map just depicting the results from that nitrogen isotope study where we looked at tissue from Limu at a number of sites in Mauiʻs Bay, and we did indeed find signatures of wastewater. In North Kihei, nutrient hotspots primarily attributed to agriculture are Haycraft Park, Kihei Canoe Club, and Kalepalepa North. So all sites over here are below former sugarcane and are also below present seed corn farming operations. In general, we expected to find that high nutrient sites influenced by agriculture would decline with the cessation of sugarcane farming in Central Maui. But looking at the data, we do see that levels seem to slightly drop between 2018 and 2020, but then they increase again in 2021. So since this pattern is emerging after the end of sugarcane ag, when we would expect to see nutrient levels dropping, we don't exactly know what the cause of this is yet. It could just be variability in the data, the fact that drops in nutrient levels from ag take a long time to detect, or from some other nutrient source. But either way, additional investigations are needed. So in contrast, we did see statistically significant declines in nitrate levels between 2018 and 2020 at Maipuʻina Oiʻiʻau. So looking at this time series, you can see that trend line is dropping. In South Maui, a major hotspot for high nitrate levels, primarily due to wastewater, is Cove Park. So Cove has very, very high levels, more than any other leeward Maui site by far. Past studies show wastewater influence from the Kihei treatment plant is present in nearshore areas by Cove Park, and this is a likely driver of elevated nutrients here. So the Cove Park has the highest values across the entire leeward Maui coast, and they are relatively stable. However, documents do show increases in the influent at Kihei Wastewater Reclamation Facility from new industrial sources are present. So we are curious, and it would be useful to investigate, if we see any changes in the data and if those correlate with differences of what's going on with the wastewater reclamation plant. At other sites in South Kihei, we also see there's no notable increases or decreases, and values seem relatively stable for nutrients here over here. Another hotspot in Maui is Ulua Beach in South Maui. So while levels are much lower than Cove Park, this site is a bit different in that nutrients are primarily derived from wastewater. So Ulua is close to Wailea on-site disposal systems and injection wells, which could be possible sources of wastewater. Excuse me. In addition, the studies have found that reef resilience studies that have found corals at Ulua Beach have a high resilience ranking currently. However, the TNC Coral Bleaching Monitoring Program, which does surveys over there and monitors some corals, has observed degradation of corals. So they've noticed that there's been high coral bleaching susceptibility and mortality. So therefore, this could be a possible place for restoration efforts to prevent further degradation. And at Ulua, we do see that trends in nutrient levels are stable. So overall, we find nutrients are coming mostly through submarine groundwater discharge. We also, unfortunately, can't address nutrients from legacy ag and groundwater just because there's so few technical solutions. However, we can, fortunately, help address wastewater and current agricultural practices to mitigate future nutrient levels. For example, upgrading on-site sewage disposal systems in key places like Wailea and Ulua, where currently the reef resilience rankings are high. Also upgrading sewage infrastructure and improving treatment of wastewater going into injection wells in the Mauiʻs area. So I'm sure many of you are wondering if we've observed any notable changes in water quality, particularly in nutrient levels during the peak of the COVID-19 pandemic when visitor numbers drastically reduced. Unfortunately, we haven't yet. Reasons for this might be because of the delay between the actual reductions in sewage and the time it'll take for those signatures to be captured or detected in nearshore waters. So there was a study, a dye tracer study at Kahekili, and it took like 14 months for them to see any changes for that dye to come through. So, it may just be that we haven't seen them yet. We also might not monitor frequently enough to catch more subtle signatures. So capturing any evidence of changes due to reduction in the number of people is kind of a long shot. However, we are working with Maui College and Texas A&M on a Kahekili specific study to see if there was nutrient reduction. And many Hui volunteers helped with this. And so we plan to share those findings once they're available. So with that, we just want to say mahalo to all of our funders and supporters. Of course, huge mahalo to all of our volunteers. Without them, this wouldn't be possible. And with that, we will take any questions.
Well, thank you so much, Tiara. That was really a very thorough explanation. And I did want to invite Tova Callender and Kim Polinsky to join the conversation here. And please do put your questions in that Q&A feature, everyone, if you have any questions. I did have one question. You were talking about the high nutrient levels at Ulua, and that's downslope of Maui Meadows, which we know has a very high number of cesspools. And I'm wondering if that factored into that high nutrient level at Ulua.
Yeah, so that's a great question. Thanks, Scarlett. Yeah, so we can't say for sure, but we do think that could be partially one of the causes. So in that area, Ulua is in that area where there's cesspools and the Wailea treatment plant. And Kim might be able to touch on this a little bit more.
Our data wasn't able to conclude that because we couldn't pull it apart, but the Act 125 is the state level cesspool working group money that supported some new research. And at Wailea, not at Ulua, they found elevated N15 levels, meaning elevated isotopes that would indicate a wastewater signature. So we can't conclude anything just yet without direct testing, but the nearby site there did show the result of those OSDS at Maui Meadows.
Okay. We do have a couple of questions that have come in. Michelle is asking, what causes DOH to close beaches?
You want me to take that one? Go ahead, Kim.
If you know, I'll let you go, Tiara. But the Department of Health has a set of state standards that are set out. So they have, there's a way to look them up. Most of the time when they're closing beaches, it's for enterococcus levels that are above their number, which I believe is, I'm going to be wrong if I say it, but they have a number. And so they'll close the beach once they see that. So they take samples at that beach and take a value over that. And then they'll test it the next day. And if it's better the next day, then they'll take the warning down again.
Okay, and I'm sorry if I missed this, but is Julio Kaiola testing for enterococcus as well?
Yeah, so we actually were testing for a while there in South Maui, but we did stop maybe, gosh, mid last year, I'd say. And Kim might be able to speak more to like the findings, but basically we weren't able to find any correlations, correct, Kim, between that
Yeah,
data.
we were successful to the extent that we were able to take good data, but we thought that it was probably best for the Department of Health to maintain that kind of data set, and that we weren't entirely sure about the predictors and the value of that metric. So enterococcus is kind of a funny standard. It doesn't always directly correlate with the thing you want it to correlate, which is human wastewater. There's a bunch of other sources. So because we couldn't really interpret the data well, we decided that we wouldn't use the parameter.
Okay.
And we were only sampling every 3 weeks. So if you think about choosing whether or not you're going to go to a beach, if it's sampled once every 3 weeks and then there's a delay in that result getting out, it doesn't add utility for the human use portion. It was more, was it relevant to the other things we were looking at?
Right. Well, we did learn that there's serious issues at Cove Park, Alua, several points on the west side, no matter what's causing them. Jocelyn is asking, have you noticed anything specific to Kaliapo fish pond? I hope I said that right. Kaliapolepo. I don't know if you're testing in there, if that's even relevant. Maybe she's asking about any negative effects in that area. But if we don't know, we can.
We don't sample, we do sample the park there. So I'm just looking at the results on my other screen here for where Kaliapolepo is ranking.
Sure.
And
Me and Tova are doing the same thing on our other screen.
Yeah.
We're looking for the answer, Jocelyn.
Yes. So, I mean, it is the fifth highest nutrient site for the south side. So that is one finding. In terms of turbidity, it's fairly low in that area. But we haven't done any additional testing to narrow down what that might be coming from.
Well, you know, while you're looking at that, let me look at Jennifer's question, because she basically was asking what I was just alluding to. Alua Beach is a favorite for snorkeling and diving. Cove Park is a hot spot for surfers. Does this survey information indicate that these are less than healthy areas? And how does human activity affect survey results?
Tova.
So in the very beginning, Tiara nicely laid out the parameters that we're sampling for. Because we are not looking at the microbiological aspect, because we're not doing enterococcus or anything else that would fall on that spectrum, the chemistry or the turbidity are not necessarily correlated with the human health issue. That being said, if water is super turbid, don't go out, because there's likely to be other things in there that you don't want. But because that human health component is not the emphasis of our program, we're not saying necessarily that high nitrates are problematic.
Yeah, the nitrates are not healthy for the reef, but maybe we should talk about where the data goes. So is this information provided to the Department of Health?
Yes, it is. It gets provided every 2 years so that it can be incorporated in their integrated report, which is their document that summarizes all of the places that have adequate data statewide, and then makes determinations about which watersheds are impaired.
Okay, so Kim, if the Department of Health knows that there are water quality issues in these hotspots, are they looking at them more closely? I know you said that they'll pay attention to them, you know, and your report adds into that every 2 years, but every 2 years seems like a really long stretch of time before a possible action was taken.
Right. So there's a bunch of different things that happen once that it gets identified as a problem. Unfortunately, it deals with a bunch of different divisions at the Department of Health. So the data that goes into the integrated report in one way makes it possible to get funding for smaller organizations to be able to try to fix non-point source pollution. So for instance, if it's diffuse problem like fire above Mauiʻs, then you can apply for grants or whatever to be able to try to fix that. For a more discrete problem like the injection, the reclamation facility at Kihei that is above Cove Park, then you have to start working with the wastewater division and have them get involved in upgrades if they think that they're necessary, and work with the county guys to say, okay, we need to do this and we need to figure out how to finance that capital improvement in order to make the change. So forgive the complicated answer, but it does depend on a bunch of different departments and both state and county agencies in order to make change.
Okay, well,
And I'm sure Tova, I can see Tova has an
No, it's a great answer, Kim, and it's a great question, darling. I'm guessing that what you're really asking is, how can we find out more about this data and get it out there? You're in luck. Our tech team with our design pro Alana are working on getting regional reports out, because that was one of our goals, that every 2 years integrated report isn't enough for sharing back with the community. So, you know, we're taking a while to really do that analysis, but we are hopeful that by the end of the calendar year, we'll have a series of reports that have the findings, that have the graphs that you can look at yourself. And that will be available at the Hui o ka Waiʻola website. So if you're on this email, we'll make sure that you get the blast out, right, guys? You do those things.
So is there any place that people can see results now, or is that the project in process that you're talking about? Anyone
can always download our data.
Okay.
It's there on the website.
And can you give us a website URL again?
It's huiokawaiʻola.com, right, guys? Yeah. .com.
Okay.
Yeah. And it's a big mess of a spreadsheet that is forever growing, because we are, as you heard, in some areas, you know, 70 to 80 sampling sessions in.
Sure.
But those more interpreted products will be coming out soon.
Okay. I know scientists sometimes don't like to make suggestions, but I'm going to ask anyway, because Karen is asking, is there any actions for fixing the Cove Park situation? And any thoughts you want to throw out about what could be changed or remedied to make that situation better?
I was going to answer with just documents, which is probably not helpful, but the quick answer is there have been studies to figure out what types of upgrades are possible to that system. The engineer in me says it's not easy to get nitrogen and phosphorus out of water. So additional treatment right now, if you just have phase 1 treatment, it doesn't necessarily get at all of those nutrients. And so they would need to have some additional nutrient practices. One thing is that up to 60% of the water in Lahaina can be used for reclamation, so to feed your golf courses and your agriculture. So that's one way of reclaiming some of those nutrients, is to be putting them to good use. There are other methods, and I'll type in the chat box just what kind of, there's some reports out there of the different explorations that they've done in order to fix the problem, but they haven't figured out how to fund yet that upgrade.
Okay. So Karen was asking, is Hui o ka Waiʻola partnering with any of the efforts for experimental grass, which absorbs nitrogen. And I assume she's talking about vetiver or something similar to that. There was a demonstration in Kihei that I actually went to. It's interesting. Are you guys looking at anything like that as, as proposing a possible solution?
Thankfully, we all work together, a small enough group of people with common interests. So Maui Nui Marine Resource Council was partnered with Ridge to Reef, not to be confused with West Maui Ridge to Reef, on that. And we also do work closely with that same outfit in West Maui. So we are keeping a finger on the pulse of how that's coming along. And as it shows itself to be viable, then that can be one of the solutions that we're hoping to put out there to expand beyond pilot.
Yeah. So the answer is yes, because you have many partners and we're all concerned. So Marty is asking, could you expand a bit on what the trend lines going through your data points and methods used to measure significant changes non-parametric?
Marty, such a beautiful question so late this evening. I'm using a LOA smoothing function to make those trend lines. And then for the statistical test, I'm using a Mann-Kendall, which is a t-test that will be able to test change over time. So those are the two tests that we're using. And if you have better statistical suggestions, I'm happy to take them personally.
Yes, Marty, do share. We know you've done great work on this in the past. We'd love to.
I believe so. Yes, please come and share. But most of the other figures were all geomeans, right? So we were taking the geometric mean, and those were the non-trend lines.
Okay. We're going to end with George Burnett. First, he says that was the best presentation ever given by the Hui. So yay, congratulations on that. He wants to know, does anybody know how state standards were determined?
Are we allowed to put Wendy Wiltsey, who I saw is usually on this call, on the spot?
Yeah, it's possible.
Or you
Go
can
for it. Go for it, Tova. I think you know the answer.
No, I'm punting to either you or Wendy.
Oh. I believe, I can't quote the year properly, but I'm going to say sometime in the 1970s, they did some sort of statistical analysis of the different types of water bodies. So throughout the state, they have type A, type AA. There's probably somebody who can answer this question better than me. But for each of the different types of water bodies, they have a different state standard, right, for each of the parameters, turbidity, nutrients, these sorts of things. The issue comes in that they've classified everything from the near shore up to where your feet touch the water out to a certain distance that's considered near shore, all within the same state standard. And it was ecologically driven to some extent. I think that some of it had to do with the Kaneohe Bay wastewater treatment upgrades when there were real water quality problems in Kaneohe Bay. So it was around the same time that people were doing these studies. And there's some old document that I've never read that goes to the rationale of that. But it does beg the question of whether those state standards are ecologically relevant in our current world.
Okay. Well, very good. I think we all learned a lot tonight, and I wanted to thank you so much, Tiara Stark, Tova Collender, Kim Felinski. Amazing work, and thank you so much for your efforts. And I wanted everyone else to know that this is part of Know Your Ocean Speaker Series hosted by Maui Nui Marine Resource Council, a nonprofit working for clean ocean water, healthy coral reefs, and abundant native fish for the islands of Maui Nui. And we're putting out a call for volunteers to help with Hui Okai Viola water quality monitoring program. What you've been hearing about tonight, they really need some more volunteers. So if this is something that you think you want to get involved in, please contact Maui Nui Marine Resource Council. They're a co-founder and co-manager of this program, along with the Nature Conservancy and West Maui Ridge to Reefs Initiative. It's a unique community-based program. It tests water at 29 locations in South and West Maui every 3 weeks. We've heard how important that is. And they provide training and materials for the volunteers. If you're interested, please visit mauireefs.org or email info@mauireefs.org. We're also looking for a location for West Maui for a water testing lab starting January 1. The ideal lab would have a sink, some counters, electricity. So if you know of a space that might work, please email info@mauireefs.org. We want this important work to continue uninterrupted. And if you support this ocean water quality monitoring effort, you could also consider sponsoring one of the 29 sites where we test ocean water. Each site costs about $4,000 per year for sampling materials and the lab testing that's performed on Oahu, plus staffing by Tiara and the project team leaders. To donate and sponsor a beach, please visit mauireefs.org. You're not going to forget that URL. Another bit of news, Tiara Stark has been awarded a grant from the National Geographic Society to characterize streams and gulches that are point source polluters of local trash and macroplastic debris to the coastline in Maui as a 2021 National Geographic Explorer. Congratulations, Tiara. Maui streams transport pollution from local land-based sources to the island's coastline and nearshore waters. Once in the ocean, this debris may entangle or be ingested by coastal and marine animals. Tiara is working to address this problem by gathering valuable data on how much marine debris is originating from various local streams and gulches on Maui and the times of year when this debris is being washed into the ocean. Her goal is to gather data that can be used to prevent land-based marine debris that originates here on Maui. And Maui Nui Marine Resource Council has just finished installing 3 really cool aqua links at Cove Park in Kihei, Ma'alaya, and Olowalu. The aqualink buoys will gather and relay data in real time, sending it to the National Oceanic and Atmospheric Administration, sorry about that, and to the Aqualink website where everyone can view it and detect coral bleaching events early. MNMRC will also be conducting site surveys of the area near the Aqualink to gather photos of the coral reef conditions and data on ocean conditions. If you love clean ocean water and healthy coral reefs, and who doesn't, we invite you to learn about reef-friendly landscaping. MNMRC recently established a reef-friendly landscaping program to reduce water pollution problems caused by the use of synthetic fertilizers, herbicides, and pesticides on land, which we are determining the water quality at our beaches and is harming our coral reefs, fish, and marine life. Like we saw, you know, we just went through all this data and we got to take care of what's happening upslope, right? We're reaching out to hotels, resorts, condos, golf courses, and businesses located near the South Maui shoreline to participate and be certified through our reef-friendly landscaping program with the help of organic landscaping expert Dwayne Sparkman. If you're interested in learning more, please email info@mauireefs.org. And to teach visitors about protecting our local coral reefs, Maui Nui Marine Resource Council's Visitor Education Program offers coral reef signs at 39 beaches, or beach locations, displays at Kahului Airport. I've seen those, they're fabulous. Radio and print ads, social media ads targeted at visitors who are on Maui, and digital display ads. This educational effort is supported by the County of Maui Mayor's Office of Economic Development. And we really do need to get that information out to the visitors, right? Maʻalaia is one of Maui's impaired ocean water quality sites, suffering mostly from excessive sediment, which harms corals' ability to feed themselves and reproduce. Maui Nui Marine Resource Council is tackling the sediment pollution program with our oyster bioremediation project in Maʻalaia Harbor, using the filter feeding abilities of caged oysters to remove sediment from the water. We've installed 10,000 caged oysters and so far and monitor them for their size and health on a regular basis. We ask you to support these coral reef conservation programs with your tax-deductible donation to Maui Nui Marine Resource Council. Along with the satisfaction of making a difference, you'll also get to choose from some pretty special swag offered as a thank you gift for your support. To donate, guess what? Go to mauireefs.org. You can view and share this presentation you saw tonight on Facebook. It's on facebook.com/MauiReefs. You can also view this and past presentations on YouTube on the MNMRC channel at Maui Reefs. And thanks again to our County of Maui Office of Economic Development and our sponsors and supporters like you who are making so much good work possible to protect coral reefs. And also on Sunday morning at 9 a.m., you'll be able to listen to a shortened interview on tonight's subject. So tune in all the stations of HY Media on Maui and rebroadcast statewide. And I just wanted to warmly thank you so much for joining us tonight. Take good care of yourself and each other and this beautiful island of Maui. Have a good evening, everyone. Bye, everyone.
Thanks. Bye.